Hi. So in this project, we're going to build a machine learning model, then mount that model on a web application that we're going to deploy on Heroku. So first, as you can see from the topic itself, we are going to build a model which is going to predict the cost of a sculpture. Now, let's first understand what we are going to do in this project itself. So we have a data set that contains information about people who have bought art sculptures from various artists. It states out some of the characteristics of the sculpture itself and the people who bought them. We will be using this data set to predict the cost of the sculpture a person has to pay whenever he is buying that sculpture. So from the data set, we are actually going to only be using a sub part of it because the dataset is not very clean or was not taken in a very orderly manner, right? So from the subset part, there were like nearly 3000 artists, I think, yeah, 3000 artists who were selling their own sculptures or maybe sculptures made of famous personalities or so, right? So details of the project. Now the project is divided into three parts. The first part is building a machine learning model to predict the cost a person might incur when buying the sculpture. The second is where we build a web app on Django to mount the prediction model. Third, we deploy the Django project on Heroku through GitHub. So the first part was building a machine learning model. So we start off with building a machine learning model and we use a random forest regressor model and train that model using artist sculpture data points. So there is abundant information on the size and shape of the sculpture and its shipping. Was it an international shipping or not? Was it an express delivery or not? And much more information. So in this particular project, we will learn about removing outliers and why it is important. So there are different kinds of data set, right? And sometimes even if you don't remove outliers from your data set, you're pretty much able to train a model which is giving you a high accuracy. But for this particular project, I will be showing you why removing outlier was very important. So the next part is, or the second part is, where we develop a Django application. Now this is the second part of the project where we will be building the web application using the Django framework. We will mount the model we built in the previous part on the Django project here. So this is the last part of the project where we will be deploying the Django application on Heroku using the connections to GitHub. So now let's move on to the first part, that was building a machine learning model. This is the first part of the project where we are going to build a machine learning model for prediction of cost of sculptures. Now as you can see, the first block here is to mount the drive folder onto this collab notebook, meaning now we can access the files stored in our drive folders from this collab notebook itself. As you can see here, you can see that the artist sculpture cost, that was a CSV file, is actually stored inside my drive folders, right? And to access that, I have to mount the drive folder onto this collab notebook. Next, you can see that I've imported some of the libraries that I'm going to use. Now, this is not the list of all the libraries that I'm going to use, but only the list of libraries that are going to be used in data manipulation, data visualization, right? So the first library is NumPy, and it is a library consisting of multi-dimensional array objects and a collection of routines for processing those arrays. Using NumPy, mathematical and logical operations on arrays can be performed easily and efficiently, right? And next is Pandas. So it is a library for data manipulation and analysis. In particular, it offers data structures and operations for data manipulating and numerical tables and time series. Well, you can see the last two libraries that I have imported are Seaborn and Matplotlib, and both of these are actually for visualization of your data, right? While Seaborn is a library for making statistical graphics in Python, similar to Matplotlib, but Seaborn helps in exploration of your data in a much more in a much more visualizing manner as compared to Matplotlib. Now, the color palette that Seaborn gives you is much more rich as compared to Matplotlib, which creates a more robust visualization of your data. So next you can see is that I'm using the function read CSV, which is of the pandas, right? And here you can see that I'm giving the path, and from this path a CSV is being called, and the data is then stored in the artist variable. Next you can see I'm using the head function. Now the head function is basically a print function which is printing the first 5 data points of your data set, since I've given the parameter 5 here, right? So first 5 points or data points of your data set. If you would have used tail, then it would have shown you the last 5 points of your data set. So as you can see, there are a lot of columns here, right? Customer location, schedule date, delivery date, and cost. And you can see the cost is in negative. So this is what I was talking about, that this data set is not really well prepared, because how can the cost be negative? It means that uh, artist is trying to sell the sculpture, then the customer comes and somehow the customer is able to get the sculpture and the money also, right? Which is not possible. So this is one reason why we have to take a sub part of it, and later on I'm going to discuss as to how was I able to take that sub part, right? So you can see that there is a lot of numerical values and string values also. There are some categorical values also, like categorical data types, which we are going to identify later on. And the first thing that I'm looking out for is the shape, that is the dimensionality of the data set. And it tells me that there are 6,500 data points or rows and 20 columns, out of which one column is actually a target variable. That is, we are going to predict that. And just to specify that, I have just given a brief of that. We are going to predict the cost, which was the last column here. So next I'm using the isNull function and the sum function. So isNull basically tells you if there is any null value present inside your column or not, right? And sum is actually taking the summation of all the null values present, meaning that artist reputation has 750 null values out of 6,500, right? Similarly for other columns also. So again, first thing that I'm doing is removing all the null values, and I'm doing that with the help of a function called drop_any. So I've given the parameter any, which means that if in a row any column is having null value, then we are going to remove that row itself from the data set. So after removing, we can see that there is only 3,362 rows present as compared to 6,500. So it's nearly halved, right? Now, if these values were less, right? If there was only maybe 50 null values, 70, 100, 150 maybe, then what you could have done is that you could have imputed, or again imputed just like I did, just removing, or you could have filled those null values with maybe median values, mean values, right? But for columns like transport, where 1392 values contain null values, we are going to remove them, right? So next thing, so this is the first subdivision of the whole data set where I'm taking the rows which has cost greater than 0, right? So only those rows which have cost greater than 0 are going to be my final data set. So you can see that some more values were removed and now I have 30 rows, 3030 rows, right? So the next thing what I'm doing is using the function describe. Now describe function actually works on data frames only, and or maybe series, and they give you a statistical information about your data set. As you can see, the first column is depicting the statistical data set. The first is like you can see the mean of the column, the standard deviation, minimum value, maximum values, and the quartiles here. So one reason why I actually use this function is to understand if there are columns which have too varied, like too much varied ranges. For example, you can see the height, right? Height column has a minimum of 3, maximum of 73. While the price of the sculpture, the minimum is 3, but the maximum goes till the power of 6. So in this way, you can see that the ranges are too far apart. So what you have to do here is either leave it as it is, but again, this is going to affect your accuracy of your model. Or what you can do is either normalize this column or just standardize this whole data set as it is, right? So you can do both of them. And what standardization helps in is that your data set becomes normalized. And once a data set is becoming normalized or is close to a normalized form, then your model is able to infer information in a much easier and accurate manner as compared to before, which again helps in increasing the accuracy of the model itself. Right. So here you can see a new function that is to date time. So what is this doing actually? You can see that the input is the column schedule date and delivery date. So to date time actually takes in string values and converts it into date time type. So your string format dates convert to date time format, as you would be able to see here also. So this is actually now not in string type, but actually a date time type, having the year, month, and date. As compared to before, you can see. So this was in actually string, then we have converted it into date time. And you will later on understand why I've done this, right? So this was just me validating if there's any null value present inside both of these columns, meaning that the conversion was not done perfectly, right? So they were 0, I was getting 0 for both of them. That means that all of the string values were converted perfectly into the datetime type. So next we are trying to find the categorical data type, right? So in categorical data type, first I'm looking for materials column, and you can see that some categories are present. And using the function value counts, right, I'm able to find out unique values present inside a column and the number of time each unique value occurred inside that column itself. So you can see that aluminium occurred 470 times, marble occurred 451 times, and so on for the rest of them. Next is the international column, which had yes or no only, meaning if the now I'm a little confused as to what international depicts. Is it asking about the artist or the sculpture where it was, or about the customer. So this is a little, I would say, confusing. But yeah, the values are yes or no only. The next is express shipment, if it was shipped through express shipment or not. So again, yes or no. Installations included in payments, again, yes or no. Then transportation, how was the sculpture transported to the customer? So there were three ways: roadways, airways, and waterways. Next was again fragile. So this column also had yes or no, and customer information, which only had two values: working class and wealthy. And well, I was a little surprised to see that there were so many working class people buying sculptures for maybe whatever reasons, right? And then last was the remote location. If the sculpture was transported or shipped to a remote location or not, right? So no and yes. So this was me looking at how many artists are present, and in our subset of the data set, right? Even in our subset, there were 3019 artists to be exact, right? So these are a lot more artists that I would have assumed before, and maybe you might know some of them. I'm not really so knowledgeable about art industry at least, right? So next what we are doing is converting the categorical data type into numerical ones. So for this we are going to start off in the next video, that is again on building the machine learning part only, right? There we are going to learn about how to convert and how to remove outliers, why they are important, and finally building the model itself. So we left off with converting the categorical data types into numerical ones, right? So first I have imported label encoder. So label encoder is one way how you can actually convert the categorical data type into numerical ones, actually integer ones. So I've built a function that is named label encoded, taking a parameter. Then I'm calling the label encoder class using its fit function to fit on the data and later on return the transformed data, right? Which means that let's say that there was a column that is material. I'm using the label encoded function on this material column. So first what happens is that all of the data from this column is fit onto the label encoder. Label encoder understands how many type of categories are present or which number is to be used to represent which category. And then once it has understood that, then it transforms the data, which means that the categories that are like here you can see aluminium, brass, bronze, clay, marble, stone, wood, all of them are replaced by numbers. Right. So this is what happens in transformation or transform. So what I've done is I've taken a list of all the columns that I want to convert. Then using a for loop, I'm using the label encoded to run on each and every column that I want to transform. And you can here see that the first column was material and the categories it had. Next was international, the categories it had, and so on till remote location. So this print statement is what is actually printing this information here. So here you can see that the string values are now converted to numbers. The no, yes, waterways, airways, all are converted to zeros, ones, twos, etc. Right. So next thing what we are going to do is talk about outliers. So you can see that I have already provided some information as to some of the columns having outliers and which value would be considered an outlier. So I'm how was I able to understand that maybe 55 and above values are actually outliers for the column height? So first, you can ignore this part for now. First, understand what a box plot is. So box plot is again a graph that depicts the information about your column or your data in the form that here you can see that a box is present and some values are defined here which are depicted down here, right? So this is for weight. Now typically a box plot doesn't look like this, right? So a box plot actually looks much better. Yeah, so you can see here a box plot actually looks like this. There's a box, then these are the whiskers, and the starting point is the minimum value, end point is the maximum value, and any value ahead of this maximum point is an outlier, or any value below the minimum or behind the minimum is the minimum, oh sorry, is again the outlier. You can maybe see here, yeah, this is a much better representation. Here you can see that there's a small dot here, right? Small dots here, small dots here. These are actually outliers. Okay, so what boxplot is trying to tell you is that most of the values are present between inside this box here. The mean is this line here. The maximum reaches till here, right? So here you can see that maybe 875 is the mean. Most values are present between 800 and 900, and max reaches little above 900. And these values are actually outliers, which are too far away from the rest of the data set. So this is actually what a box plot looks like. But you can see here for the weight column, the box is squished down and looks like just a line, which is represented by 0. And if you are able to understand, all of these points from here till here are actually just outliers only, which means that this column has so many outliers. And one thing that I would like to tell you is that later on here, I'm removing the outliers. What you can do is just comment these out and run the script and see how much accuracy are you able to get. And once you have done that, just note that down. Next, uncomment this and again run the script to see the accuracy. You will be able to see a very good accuracy as compared to before. It might occur that maybe 20 or 25% of accuracy was increased, which is a lot, right? So this is one reason why we are removing the outliers. So as you can see, the weight was having so many outliers, right? So what I did was here I took all the columns, right? So it is depicting all the names of all the columns. So what I did was I looked out for each and every column that was already having numerical values to see which of the columns were having outliers. And from this, I was able to get the outliers and from where the outlier starts, right? So next, you can see that I have actually removed the outliers now from all the columns, right? And now here you can see that a better box plot looking graph is shown here for height, which is telling you that most of the values are present between 10 to 30, with the mean a little behind 20, minimum is somewhere here, and maximum is somewhere here, right? So this is actually good data, and it won't confuse your model into training a little varied data which might having a value too much far away from the general values in that column, which again decreases your accuracy or the accuracy of the model. So there's one reason Even though weight has so many outliers, I haven't included that here. And the reason will be shown maybe later on. Yeah, here you can see that the weight is actually pretty much correlated to the cost here. And I will tell you what correlation means, right? But before that, you can see again that again some of the rows were removed, and now my final data set, or I would say pre-final data set, has 2765 rows only. So I've dropped the columns that are of no use to me: customer ID, artist name, customer location. Some people can actually use this, but for this project, I have just removed that. Next, I am building a correlational graph. So you can see that x.cor, which is the correlational function, and I'm using a heat map that is inside the Seaborn library. So what is a correlational graph? What is correlation? So correlation is basically a measure of how closely related one column is to another, or one entity is to another, which means that this graph is actually giving you values, telling you how much correlated maybe artist reputation column is with height, right? Artist reputation column is with width, with weight, and so on. So from here, you can see that most of the values are between 1 and -1, so which is also true. Correlational values are between 1 to -1 and both inclusive, meaning that if a value is 1, that means that art maybe entity 1 is perfectly correlated or directly related to entity 2, which means if there's going to be a change in entity 1, there's going to be an equivalent change in entity 2 also. And a -1 represents that if there's going to be a change in entity 1, there's going to be an inverse change in entity 2, right? So with this, you can see that some of the values are pretty high, like 0.75, 0.74. So it depends on you as to what values would you consider to be high. Some might even consider a value of 0.53 to be high, right? So it's totally on to you. And the reason why we have actually graphed this out is because from this you can understand which of the columns are actually affecting your cost column. You can see a value of 0.41 means base shipping price is actually affecting the cost, or is actually helping in determining the cost. Price of sculpture again is helping in determining the cost, but weight is also helping in determining the cost. Now you can see that these values are pretty much higher as compared to 0.2, 0.24, and all the rest. So that was one reason why I haven't, you know, removed or used the same function to remove the outliers from the weight category, because weight category or weight column is holding a lot of information that is helping in determining the final cost. So next, yeah. So next I'm actually creating a new column that depicts, okay, so that depicts the time from scheduled date to delivery date, right? I've just now realized that I've reversed the role. What I wanted to showcase was that the time frame that it took from the scheduling of the sculpture to be sold and time till the sculpture was in the hands of the customer. So it would have been delivery date minus schedule date, not vice versa. But then again, I've already done this and just now realized. So you can see that the waiting time is this. What is surprising is that the values are positive in some cases, because that means that the thing was delivered already, and after that it was scheduled, which is kind of illogical. So another reason you can see why I was telling that this data set was not properly prepared. So you can see the waiting time now is showcasing the number of days here, right? So if the reason why I actually changed from string to date type was because of this, because then I was able to use algebraical operations directly on dates, and I was able to get the number of days that it took, right? Which was my main motive. So what I'm doing is just removing the days to just get the numerical values. And for that, I've just created an extracting size function, not the name that I should be using, but then again, okay. So what I'm doing is I'm splitting the data. As you can see here, the first value is 1 days, right? So this is actually holding 1 days as a date type. Again, 1 days is not string, it is a date type. So I have to convert it in string first, then I'm splitting on the basis of space and only taking the first part, that is 1, or the number itself. So similarly, what this is what I've done. I've taken the number and converted it into the float value, right? So it might happen that sometimes your data might not only contain date values, right? Here it might happen that some row had a null value present because of whatever reason, right? So for that I'm using the try and except case, so that if there's going to be a null value, this is going to give an error here. So it would go into the except block and I would count. So later on I'm able to understand that there are some null values present inside the data. So either I have to fix that or remove those rows. So later on, I got to know that the count was 0, meaning all of the values inside that column, waiting time, had date values. There was no null value present. So I've used the map function here. Map function tells you that if you're going to input a function here, right? So it is going to apply that function on each and every value inside that row, sorry, that column. So now here you can see that all the values are now float values. So finally, I've created the final dataset that I'm going to use to fit in the model. And now I'm calling out the libraries for training and testing, that is splitting the dataset into training data and testing data, my random forest regressor, and accuracy score. Well, I've also imported PCA, but I haven't used that. So using the train test split, I got the training and testing data. Using random forest regression model, I have called the model here with estimators as 200 and njob is equal to -1. Basically telling the computer that you have to use all the processes to train the model. I have fit the model and got the accuracy, which is 97 percentile, pretty high. And then the X test, that is testing accuracy, which is 84. Not so high, but kinda okay, right? You can go on and try to increase the accuracy here. Maybe do something more about the outliers or maybe use standardization. It is going to help in increasing the accuracy. But this was okay enough, so I left it as it is. So the last part is again storing this model so that I am able to mount this model in my Django application. So with this, we have completed the first part, and now we will be moving on to the second part, that is building the web application. Part of the project where we are going to understand and build a web application using the Django framework. Now we are not exactly building a web application, but we are going to use a base that is again provided by Django itself and try to upgrade it or add functionality, sorry, in a way that we want on our website. But before moving forward, let's understand what Django really is. So Django is a Python-based free and open source web framework that follows the model template views architectural system. It is a web framework that has a set of components that help you to develop websites faster and easier. Now, you might be thinking what a model template views system is. So, in the Django project itself, there are three very important components. The one is, which is called template, is actually referring to the HTML pages or the CSS files that are upgrading the HTML pages, right, on your front end. The views is actually the backend part implemented in the Django itself, and the models refer to the tables like SQL tables or so, which store maybe different kinds of data, right? Which you might be showcasing on your site itself or maybe using in some other way. So this is what the model views templates architectural system means. Moving forward, let's first set up the code so that we can later on understand and use it. Now, first thing that you have to do is create a project directory. Then you have to build an environment. So for me, I just created a directory that is artist, and then I build an environment for this project. You can see on my command line, the environment is activated. Now, if you're using PyCharm like me, what you have to do is go to the files, then settings, and once the pop-up opens, you have to go into the project and then click on project interpreter, and here you're going to see the environment. If there's no environment specified here, you can just click on the settings button here and click on add. So another pop-up opens where you can just create the new environment however you want, right? So I've already done this, so you can see that this artist environment is already working and these packages are installed there. Now you don't have to install the packages one by one. All you have to do is go to your command line, and inside my site directory, you just have to run this command here, right? Pip install -r requirements.txt. So once you do that, then all the dependencies and packages that are required by this particular project will be installed, right? Then you can start using the app itself or the project itself. But again, before doing that, there's one another, I would say, command that is specific to Django that you might have to run, which is python -py migrate. Now, migrate is a command that asks Django to instantiate all the pre-existing models that are required by the project itself to run. What I mean is that in Django, you don't have to build everything from scratch. If you run a command that is Django admin start project and then the name of the project, then a project is developed, which means that a base project is already provided to you. And on top of that, you can say build new functionalities that you want on your website itself. For more information, you can also visit the Django docs. They are pretty easy to understand and have a lot of visualizations also as to which command you might be running, maybe the server itself, or you might be making changes in the models. Those are the tables, right? So once you have done or once you have run the command migrate, you can start off with running the server locally and running the project itself. So I would be doing that later on. First, I'm going to showcase what a project is and what an app is, right? Then I'm going to explain how the Django application is actually working. So first, as you can see on the left side, the my site directory here is the project and the polls here is the app. So basically this project or this folder has a settings.py file. So once you go in that, you can see that a lot of settings are already set up, and you can see that a security middleware is present, session middleware is present, CSRF middleware is present. You can here see that authentication, there's an app for authentication, there's a content type, sessions, right? So as I told you before, Django already provides you with the base application which you can directly run also. So here, those base application already has a lot more functionalities present where you don't have to create them from scratch. You can update them or maybe make changes in them, but they already are present in the base project itself. And that is also shown here. So next you can also see the databases, right? So you can connect different databases to your Django application where the models will be actually working with the database itself. So you can join different databases which might include MySQL, maybe Postgres or some other type, right? And last you would be able to see the static files. So this, or I would say these two lines are actually settings for static files, that in the static root, all the static files will be present, and to access a static file, you will be using the static URL. Now, this might not be good enough of an explanation as to what these mean. So what you can do is maybe again go back to Django docs or just directly Google itself what static files are and how Django handles them. Because static files, as you can see, include CSS, JavaScript, images, right? Which are usually used for extra functionality on your HTML pages, which, as I've told you, are called templates in Django definitions, right? So you can make changes in settings as however you might want, because if you're changing your settings page, right, maybe some settings related to templates or databases or static files, then those changes will be occurring at all the places inside this project, right? Now the difference between a project and an app is, so a project is like a base website which Django provides you, onto which you use different kinds of apps to build functionalities that you want onto your website. For example, I built an app Polls, right? So this app is called Polls and it has some files, right? And here you can see a file named views.py. So views.py actually is the implementation of the backend itself, right? So here you can see a lot of variables are present and I'm creating a data frame, right? So before actually explaining what all is happening here, let's go to the HTML page. So you can see that I've created an HTML page which has a form in it, right? Form in it, and then the above part is just the CSS. So I've created a form, right? And once I created the form, what happens is that a person visits the website, sees the form, then starts to fill up the form, and lastly, he goes to the submit button and clicks on the submit button. Now, what happens is that once the submit button is clicked, all of that data which was in the form goes into views, right? So, actually, all these variables are storing the value that are coming from the front end, that is the form, to the backend, which is the views right now. So once the data is here, what I'm doing is creating a data frame out of it, right? I create a data frame out of it. Then I'm feeding that data frame as my data to the model. So here you can see that I'm mounting the prediction model, right? So I've pickled the file. So I'm calling the pickled file here as loaded model using the function load from pickle itself. Then I'm using the function predict to predict my cost using the data that was stored in data frame df2, right? So once I've done that, I'm returning that result using the context back to the front end. So this is the simple cycle of it, right? You might be thinking what is happening here, right? Render, then there's a request parameter, then the HTML page itself. So what happens is that in our views, we create functions, right? We create functions and each function is mapped to a specific HTML page. Meaning, whenever you go onto a site and that is based on Django application, right? What happens is that whenever the path is clicked, the URL is clicked, then a function is going to run. And that function is going to render the specific HTML page itself, which in our case is index.html, right? But you might be thinking that, yeah, path is there, or maybe a URL is there, but there's no call for this index function. We have just defined it here, right? So there's a file that is urls.py, and if you go inside there, you would see that we have defined URL patterns where a path is defined and it is mapped to a function, right? So this is what happens. Once you go onto that path, URLs understand that, yeah, this path was accessed, so I have to call this function. Once URLs understand that this function is to be called, then it goes to the views and understand that, yeah, index.function is to be called, and here you can see that we are rendering the index.html page. Thus, we are going to render this page when we are going to go on to the specific path. And once that happens, so you will be looking at a form, you fill up that form, again, click on the submit button, that data comes here, the processing is done here, and finally the result goes back to the HTML page itself, right? So this is how basically a Django application is rendering a page and retrieving and storing the data. So as I told you about the command that was run server, so we're going to use that command, right? So once you click on that, it is going to take a little time because now it is going to start a development server onto your local machine and provide you with the localhost URL. Now you can see that there are 18 unapplied migrations here, right? Which means that we haven't run the command python manage.py migrate. So the tables are not instantiated yet. So before actually going to the site itself, we are going to run the migrate command also. So now you can see that a lot of tables are being created, a lot of tables are being altered, right? Next, we again use the run server command, and now again it takes a little time. So it creates a development server onto your local machine and provides you with the local host URL. Once you click on that URL, you will be, yeah, you can see that the page is now loaded and you can just fill out the form, right? Fill out the form and then fill the whole form and click on submit, and then later on you will be getting the result onto the bottom part of the page, right? So this is how Django application is working, and this was the second part of the project and we have completed that. Now again, we didn't create a application from scratch. We just used a command that's providing you a basic project onto which you're creating new things or new apps specifically, right? As I created the polls. So with this, we have completed the second part and we'll be moving to the third part, that is deploying the site or deploying the web application on Heroku. This is the third part of the project where we will be deploying our web application on Heroku. Now, before we start with Heroku, we have to use some files which are like commands for Heroku to understand. So let's start with runtime.txt and proc file. Now runtime.txt is basically just telling Heroku which language or base is to be used by the server. As you can see here, we have specified that we are going to use Python and the version of it, right? Now next is the proc file. So proc file is the mechanism for declaring what commands are run by your application in Heroku platform. The commands that are specified in the last part, like run server and migrate, so these commands are actually executed in Heroku server using the proc file itself. And with that, it also creates a log file so that we can get to know what is actually happening in the server itself and at what time did it happen, right? So before actually deploying on Heroku, we have to upload our code on GitHub itself. So what you have to do is just go to GitHub and not deploy, but upload the code. So this is what I did. I uploaded the code, which was like my site, where all the project files were present, like settings.py file, URLs, and the other files. Next was the polls, which was my app, and flow and proc file and all the required files, right? So you have to actually upload the files in the same exact order itself, because if you're actually uploading the files in maybe just one folder or maybe 4 or 5 folders which are named different or maybe not really related to the app itself, then Heroku is not able to actually deploy your code properly, because it is not able to understand that if that folder or that file is really related to the app itself or not. Right. So once you have done that, go to your Heroku account. If you don't have one, you can just create one. It is very easy to do so. And once you log in into your Heroku account, you will be redirected to your dashboard, right? Personal dashboard. And what you can do is just click on the new here and then click on create new app. So once you do that, you can just click on and type in any app name that you want. There's only two regions to select from, right? Next, you can just click on create app. So I've already done this. So you can see that once you have created your app, it would be listed out in the personal dashboard itself. So click on your app, then first go to the settings, which is here. So click on settings, then scroll down to build packs, right? So click on add build pack, then click on Python and click on save changes. So once you do that, here Heroku/Python build pack will be specified, which is what Heroku will be using when we are actually deploying the code. You can get a brief of what build packs are from here, right? Next, you have to go to deploy. So in deploy, the first thing that you can see is the deployment method. Now there are three ways that you can deploy. One is using Heroku Git, right? That's the CLI for Heroku. Just like how if you're going to use Git Bash, right? Next is GitHub Connect, and the last is container registry. So we are going to use the GitHub Connect, and once you click on that, it will ask you to log in into your using your credentials, and once you do that, your GitHub account will be connected to your Heroku account. So next thing that you have to do is, here there's going to be something that is going to ask you to connect a specific repository to your app here. So it is going to give you a maybe search option where you can search the repository name. Once you search that, it would ask you to connect using a connect button. Once you click on that, it is again going to show you something like your ID, your repository name by your ID, and a disconnect option here, right? So once this happens, go and scroll all the way down to manual deploys. Now in manual deploys, you just have to choose the branch that you want to deploy, right? As my main code was in master branch, I'm going to choose master, then click on deploy branch. Now, once I click on this, a set of processes start that is actually automated by Heroku, where now it is going to take in your code from Heroku, understand it, and start to set that up onto its server. You can see that it is saying that Python version specified. Yeah, wait a minute. Python version specified in runtime.txt. So the server knows that it is going to use Python, but which version it is taking from runtime.txt. Next, it is actually taking the requirements, right? So here it is installing all the requirements or dependencies that are required by the code. Next, you can see that there's a, wait a minute, yeah, there's also a Python manage.py collect static no input. So again, this is a command that is specific to Django, and with the help of the proc file, it is running that command, and this command actually specifies that all the static files present all over the project and the apps are to be stored into static files only. Okay, so once that happens, it is lastly going to compress the files, and then your server will be ready to use. So once that happens, it will tell you that deploy to Heroku with a tick sign, and a view button will be here. Once you click on that, your code will be running on the server, and then you can just maybe type in your name, right, and fill the form. So this is going to take a little time, but yeah. Once you click on the submit button, you can see at last that the cost will be this, right? So with this, we can see that we have completed the third part also, which was deploying on Heroku. And with that, we have finished our project itself.